Okay, so let's practice on some examples. So here are some sequences. So the sequence is AK, and we have AK given in our explicit formula. So I have to find the limit of the sequence. So step 1 would be to first write it as a function, and that would obviously be x over 1 minus 2x. And now we want to know as to what is its limit. So the second step would be I want to find limit as x goes to infinity, x over 1 minus 2x. But these are the kind of questions that you have done before many times. So if you remember, what we do is divide the numerator and denominator by an appropriate power of x. So in this case, x is a good term to divide by, so I'm going to divide the numerator by x, and I'll divide the denominator by x. If I do that, I get 1 over x minus 2. Now as x goes to infinity, this will go to 1 over 0 minus 2, and that is negative half. So therefore limit k going to infinity of the sequence is the same as the limit of the function, and that is negative half. So that's how you would finish the question. Now let's look at this one. So here f of x would be 1 minus 5 x raised to the power 4 over x raised to the power 4 minus 8x cubed. Now the good term to divide by would be x raised to the power 4. So I'm going to divide both the numerator and the denominator by x raised to the power 4. So I get 1 over x to the power 4 minus 5, and downstairs I would get 1 minus 8 over x. Now as x goes to infinity, this one goes to 0. The next term is 5. In the denominator, I have a 1 minus 0. So that means the limit is negative 5. So the answer is negative 5. Okay, continuing with the next one, we clearly see that there are two separate terms here. So I could first find the limit of this, and I could find the limit of this. So let's do them one by one. So suppose I'm working on this one. So we know very well I'm going to divide the numerator and denominator by x. So I would get 1 plus 1 over x, and in the denominator I would have 2 plus 3 over x. So that gives me 1 over 2. This second term, as whether you can call it k going to infinity or x going to infinity, it obviously goes to negative 1, because 1 over k becomes 0 as k goes to infinity. So the first term limit is half, the second one is negative 1. So from the theorem that we had earlier on, the limit of ak would be half times -1, so it's -half. Now let's look at part D. The function f of x would be log of x plus 1 over x. Now in this particular question, obviously we cannot use algebraic methods, and as x goes to infinity, you have infinity over infinity form. So we are going to use L'Hopital's rule. So the L'Hopital's rule says, just to quickly remind you, limit x going to infinity of f over g is limit x going to infinity of the derivatives f prime over g prime. Again, reminding you that you're not supposed to use the quotient rule. So let's do the derivatives. Log of x plus 1, the derivative would be 1 over x plus 1. And the derivative of x is simply 1. So you are left with 1 over x plus 1. Now as x goes to infinity, this goes to 0. Therefore, limit k going to infinity of this particular sequence is 0. 0 is the limit. The same thing with this one. My function is x over 3 raised to the power x, and again this is infinity over infinity form. So I'm going to use the L'Hopital's rule. So that's going to give me the derivative of the numerator is 1. The derivative of the denominator is 3 raised to the power x times ln of 3. And clearly, as x goes to infinity, this is going to go to infinity. So who cares about ln 3? And you have 1 in the numerator, so this also goes to 0. Therefore, limit k going to infinity, ak is 0. Now you've seen in this section on sequences, the most important thing that we need to be able to do is to find the limits of these kind of sequences, and this will be required in our next section, which is infinite series. And why do we require it? I'll explain it to you in that section.